All right, guys. So, uh, let's see. I had to restart this. Let me see if I can remember what I said. Um, One thing is, I don't know yet how I'm going to work assessments and homework and all that. Just keep doing the homework. Just keep trying the handouts. I think I told everybody in an earlier video that we ended up being a little ahead of where I needed to be before this crazy ass week came before us. So this is why I don't have like a ton of stuff coming at you. I'm certain you're okay with that. You have enough stuff to worry about. You have some teachers that are better than me with pure online business and some that are worse than me. So I'm sorry. So you got enough to worry about. So just for the moment, I know I will eventually figure out how to do assessments that I can trust, so that everybody can actually start getting, figuring out what your whole grade's going to be. So just for the moment, just keep working, keep reading, keep watching stuff. All right, just keep your eyes on emails and Canvas. All right, so what I'm going to do, there was a central limit theorem practice worksheet that I included at the tail end of a video I posted called New Video on Central Limit Theorem, Chapter 7. Um, Let me see. Yeah, so the very first problem had to deal with bone density in females. So it tells me, generally speaking, that the mean for all women is 2.9 units. Grams per square centimeter, which is freaking me out. It should be cubic, but oh well. I think it should be cubic. And then standard deviation is 0.31. And they asked me in part A, we take one woman, so that's why this is good. And it tells me it's normal. This is huge, of course. Huge. It's got to be normal for me to eventually be able to use sheet of answers. Okay, so that's what they tell me. Sorry, I just rocked the whole world. And they ask me, find the probability that one woman will have a bone density greater than 3. So she's like, approaching Wolverine status, I guess. I don't know. Maybe not quite adamantium, but I will. I know it's normal. I can draw the picture. I can put the mean in the middle. I can put my little 3 over here. And I want to know greater than 3. It's normal already, so I don't need n greater than 30. I know the standard deviations for individuals, so I can make a z-score out of this, right? Somewhere there's a parody of the Mulan thing. I can make a z-score out of you, but no, I'm going to stop. 0.31. This should be 3, I think 0.322. See, 0.1 divided by 0.31. Yeah, you can see my earlier stuff. So anyway, 0.323. So 0.32. I like it. Boop, boop. So now I know the z-score for this. I can look it up. And of course, when I look it up, I'm going to find that side. We should all be kind of familiar with this by now. So 0.32, I get 0.6255. 0.32. I've already forgot what I said. This is really remarkable. 0.6255. Okay, so 0.6255. So then my answer is going to be 1 minus that, 0.3745. Pop! All right, I like it. So almost a 37% chance that some individual woman will have greater than 3, right? Okay, so now part B, same situation, bone density of women, but now we're taking 22 women, and they're asking me the probability that the mean of those 22 is greater than 3. That should be more difficult to do than just finding one woman with a bone density bigger than 3. So the very, very first thing I'm going to do is figure out what my actual new spread is. So it's the old standard deviation divided by the square root of the sample size divided by square root 22, pop, 0.066. I like it. Where am I? Okay, so now now we basically, that's the only new thing. We used to be able to just use the standard deviation they gave me. If I take a sample and I ask about the sample mean, I have to create my own standard deviation based off of that for a group of 22 in this case. 22. So now I still have the same picture. Mean is the same. Standard deviation changed. So now when I go to make a z-score, it's going to be my data point minus the mean divided by the appropriate spread, which is 0.066. So let's see. 0.1 divided by 0.066. I get 1.52, much further away than it used to be. And when I look up 1.52, I get 0.9. Oh, sorry, that was a really bad one. 0.9357. Oh, crap. You can't really see that. So then the answer is going to be 1 minus 0.9357, which is 0.0643. Okay, so about a 6% chance, almost a 6.5% chance, that a group of 22 women will get that far away from the mean. That should make sense that much fewer groups of women are that far away, because any average of a group should be close to the actual average. That's why the answer came out much smaller here. One woman could be that far away, but a group of women? Shit, no. Okay. All right, so let me kind of get all that in there. Okay, so you could pause there if you like, somewhere here. I'm not going to mess with the way a camera's set up. That's for damn sure. I'm going to pause. All right, look at that. It's like magic. It's like I drew a genie magic. Stop the camera, magic happens. So, let me see if I could do this for myself. Is that better, Jeff? A little bit. Okay. Let's look at part, let's see. That was 1, all about the bone density. 2 is about life expectancy of California infants in 2004. It kind of sucks that life expectancy actually went down a little bit over the recession, but that's expected. So number 2 says the average life expectancy is 80.2 years with a standard deviation of 14.9 years. Part A says, part A is more conceptual. If we select 37 infants, why is it okay to use a z-score chart? Well, because n equaled 37 is greater than 30. So central limit theorem says go for it. It says it is normal enough. Normally enough for what? Normal enough to use the chart. Yay, the chart of answers. Okay. Part B gives me an actual question. It says find the probability that the sample mean for those 37 people is less than 75 years, right? We want this group of people to die before they hit 75. So the very first thing I need to do, again, I took a sample. I have a question about the sample mean. Therefore, I need to change. You know, I have other colors here. That would be amazing. Let me see if I can branch out. I need to change my standard deviation. Look at that. That's a huge change. It used to be 14.9. If I divide by the square root of 37, what do you think that's going to be, Jeff? I don't know. 2.5. 14.9 divided by the square root of 37. 2.4 something. 2.45. Okay. That averages out. 2.45. Oops, 2.4495. Yep, 2.450. All right. Remember, you got to go at least 3 places. And again, we change the standard deviation. Now we can do the problem like normal, like we always do. 80.2 is still the mean. I'm curious about less than 75. So then I change 75 to a z-score. My data point, 75, minus the mean, divided by the new spread here, the spread that works for groups. What do you think that's going to be, Jeff? I don't know, man. 2.17. 75 minus 80. Scheisse. 80.2 divided by 2.45. Does that look right? Yeah. I don't even remember what I said. But I got negative 2.12. Negative, Jeff. Come on, buddy. Negative equals negative. There we go. Sort of. All right, you guys got it. Jeff, calm down. It's fine. It'll work. It'll be all right. All right, I'll stop. So negative 212. So when I look that value up, that'll be the answer. Yay. That kicks ass. Because it wants area below, and the chart tells me area below. Negative 2.12 is 0.0170. 0.0170, yes. Done. All right. Oh boy, now we got 2 more problems here. Can I fit this in? No. Time to pause again. Everybody got this? All right, magic. Okay, so I've got all the information left on here that I still need. So now part C. Do we want to try like a third color? People like, we don't give a shit, Jeff. Just do the problem. All right, jeez. Sure, we'll do it up here. So part C says probability that X bar, the sample mean of these 37 people, is between 81 and 83. So they live between 81 and 83 years old. I have to change both of these to a z-score. So let me see. Let me first draw this picture. Let me see. Can you guys see that? I'm going to revert back to black, I think. Put the mean in the middle, 80.2. And I want between 81 and 83. Ah, crud. Look at you. I don't care. So let's see. 81, 83. So I need to just make both of those into z-scores. Let me see. I'm going to pause. Well, okay. So there. I just want to pause so you didn't have to watch me writing all this stuff down. But if you get the z-scores for both, it should be 0.33 and 1.14. So get that work. I'm going to erase it. Look at my high-tech eraser. Yeah, about as good as what I got at the school. So 81 was 0.33. And 83 was 1.14. So now if I look up 1.14, it's going to be too much. I just want this area here. When I look up 1.14, I get 0.8729. And when I look up 0.33, I get 0.6293. Right, 0.6293, yes. So the actual answer is going to be 0.8729 minus 0.6293, right? Where'd it go? Oh, why do I feel like that's wrong? No, this looks fine. Okay, so let's see what we get. We get 0.2436, I think. 0.2436, I believe. 868.729. 8729. Okay, good. So 0.2436. I like it. So 24% chance that this group of 37 people will die somewhere between 81 and 83. All right. Let's see. Oh, we're coming up on the hard stop of 15. Let's see. It's going to be a little longer, 15 minutes. Too bad. Part D is a little bit weird. Sample mean ages. Bounding middle 95%. So this has got a few weirdness things going on. Jeff, you can do it. There you go. Middle 95% looks like this. Here's the middle 95%. Now realize that the chart doesn't understand this for shit. If there's 95% in, there's 5% out, meaning there's 2.5% there. I can look at that z-score then. If I look up 0.025, I will get 1.96 eventually. 0.025, look at that. It's like perfect, 0.025. Can you guys see that? 0.025, there it is. And that's negative 1.96. So this is positive 1.96. So now, remember this formula here. Put it down there, Jeff. Here it comes. There it is. this formula, but we have to use the new standard deviation now because it's a group of 37 people we're talking about. So now it's going to be, and notice this, I want to go up and down 1.96, right? The z-score is positive 196 to go up and negative 196 go down. So let's see, it's going to be 80.2, give or take 1.96 of these was 2.45. All right, so if I put in there 1.96 times 2.45, 4.802, 4.802. So then I end up, so then watch this neat stuff I could do, store in X. 80.2 minus that, 80.2 plus that. I get 75.4 roughly up to 85 basically. So those are the two sample mean ages that captures the middle 95%. 95% of all groups of size 37 will live to be will live to be within these two ages. Okay. So again, that was that handout that started off with the bone density stuff. It's up on Canvas right after that one video I posted. So if you didn't get that handout, you should go do it before you pay too much attention to the answers here. You should try it out on your own. Okay, so hopefully I'll get some things figured out soon. I am still wide open to suggestions. Let's look at this side of the So yeah, all right, that's enough for this one. Where am I at? 16, almost 17 minutes. Oh shit. All right. Bye, guys.